Hello everyone, my name is Ryan Dixon. I'm a PhD student at the University of Florida, and I'm going to be talking with you today about managing nutrients in some of our greenhouse crops. So a common way to deliver nutrients to container crops is by using water-soluble fertilizers. And we mix water-soluble fertilizers in our irrigation water, or more commonly inject them into the irrigation water, so that every time we irrigate the crops, we're actually fertilizing them. Typically, we supply a full range of nutrients in the fertilizer, so that we're giving the crop all the nutrients we irrigate. So the way we apply nutrients is, it doesn't matter whether we apply from the top or from the bottom, both ways are acceptable. Now, another way that we can apply nutrients to container crops is by using controlled release fertilizers. So controlled release fertilizers will supply nutrients slowly over time to the crop. This is an example of a krill. There's water-soluble nutrients inside this krill. It's wrapped in a polymer coating, and water enters this krill, solubilizes the nutrients, and then the nutrients diffuse out into the root zone and are available to the plants. So we can either incorporate this into the media in the container, or we can top dress by sprinkling nutrients on top to deliver nutrients that way. And the rate in which the nutrients leave this krill is dependent on the temperature of the growing medium. Okay? So the higher the temperature, the faster nutrients dissolve out of the controlled release fertilizer. The lower the temperature, the slower they dissolve out. Okay? Now, when we're managing nutrients, and we want to make sure that we're applying an adequate amount for plant growth. So one of the ways that we monitor the nutrient level in the container is by measuring the electrical conductivity, or EC. So if the electrical conductivity is a measure of the total amount of nutrients in the container, and we have portable meters that we can bring out to the greenhouse to measure EC. So if the EC, for example, is too low, that might indicate that nutrients are not adequate, and we need to increase the rate of fertilizer that we apply for the plants. If the EC is too high, okay, that would indicate that we're supplying too much nutrient to the plant, and we can fix that by reducing the concentration of fertilizer that we apply. So as plants take up nutrients, okay, as plants grow, they'll take up nutrients, and we might have to increase the amount of fertilizer that we apply over time. So here we have a tray of small plants, okay, small containers. And one thing about small plants is that they they're smaller, and they're usually growing at a lower rate, and so the demand for nutrients is not as high as it would be, say, with a larger plant like this. So we would fertilize this plant with higher concentrations of either water-soluble fertilizer or controlled release fertilizer to supply to this plant. And we would typically supply lower nutrients to young plants. In these containers, we have an organic growing medium. We're supplying nutrients through an organic turkey compost. Now, one of the main things to consider when using organics is that delivering nutrients is a little bit more complicated. Okay? With organic fertilizers, the nutrients have to be broken down by microorganisms. This usually takes time. It depends on temperature and water in the container, as well as oxygen. And so the challenge sometimes with organic fertilizers is that we're not supplying nutrients fast enough to meet the plant demand. But we can check the EC in organic compost in containers, just like we would with our water-soluble fertilized crops, to see what the nutrient level is. Sometimes organic composts have very high salt levels, particularly sodium and chloride. So that's something to look out for when like pH organic media. Sometimes the pH is a little bit high in organic media also, which can cause some nutrient availability issues. So one important aspect of managing nutrients in container production in greenhouse crops is pH. So pH of the growing media controls the solubility of a lot of the nutrients. So if the pH is too low, we get high solubility of certain nutrients and we get toxicity. If the pH is too high, we can get low solubility of some nutrients and get deficiency. And so we need to keep the pH slightly acidic, around 6, in order to ensure adequate nutrient availability to the crop. With water-soluble fertilizers, one way we can do that is by using fertilizers that lower the pH or increase the pH to manage pH into an optimal range. Over here, we have plants growing in hydroponic systems. So these are nutrient film technique systems where nutrient solution is being pumped up through the system. There's a thin film of solution that's flowing down the trough, and the plants are able to take up nutrients from the thin film in the bottom of this trough. So you can see that the roots in this cell are extending out of this is a rock wool cube. They're extending out into that thin film of nutrient solution. They're able to take up fertilizer that way. So the principles of nutrient management in hydroponics are very similar to the principles in organic or in traditional container production. We still need to manage the level of nutrients that we apply in pH. So if plants, as they grow, and these systems will take nutrients up, we can measure the EC in the nutrient solution. If it's too low, we can add more fertilizer. If it's too high, we can add clear water to reduce the amount of nutrients to apply. Now, in hydroponic systems, we also have the option of using organic fertilizers. So in this trough here, we have plants that are being, there's a recirculating liquid organic fertilizer that the plants can take up nutrients from. And this is a sample of the water that's recirculating through the system. And you can see that it's dark brown. There's a lot of suspended solids and gunk in here. And the nutrients will be slowly available through microbial degradation. So it takes time for the nutrients to become available in these types of systems, which is a challenge that Gerard must consider. We also have another organic type of system that you can try where plants are basically growing in an organic media, very similar to a compost, in a lot of cases a compost, where the roots can take up nutrients from the organic compost in this basket here, and then they wick water up from the bottom of the trough to get water that way. And we have this is a sample of the solution that's circulating through this type of organic system, and we still have some suspended particles and slow release nutrients coming from the water. Back here we have some different hydroponic systems. This is a kind of a deep culture system. We have a raft system. This is a deep flow system where plant roots are sitting in a larger pool of nutrient solution, and it's being recirculated through. And the principles are the same. And managing nutrients really comes down to just checking the nutrient level in the water and making sure it's at the adequate level, and also managing the pH. The same principles apply to those systems as well. Just to recap some of the common ways to apply and manage nutrients, we have our for our traditional pot systems, we have water-soluble fertilizers that we can apply either from over top or sub-irrigate and let wake up the media. We have controlled release fertilizers that we can apply to containers either on top of the soil or incorporate into the media to slowly release nutrients over time. We have organic fertilizers and organic media that slowly release nutrients through microbial breakdown of those nutrients. We need to be aware of the size of the plant and the nutrient uptake. For small plants, we'll apply lower concentrations of fertilizer. For larger plants, we'll apply higher concentrations of fertilizer to meet their nutrient demand. And in hydroponics, the same nutrient principles apply. Check the nutrient level, manage the pH. pH in hydroponic systems we can usually control by adding mineral acid or liquid base to lower or increase if we need to. And we have some options to grow organically in hydroponics as well, using the same principles. So, thank you very much.